Okay, guys, so now that we are finally done with, and by the way, hi guys. I recently recorded a video regarding the college algebra final exam. So now that we are finally done with that, what I want to do now is study, or go through precalculus, because precalculus is after college algebra. Precalculus is the next level of math that one would take in their, if you're a math major or if you're minoring in math, that's the next level of math that you would take. So in this video, what I want to do is just go chapter by chapter. I'm going to do a chapter per video, or rather maybe a section per video, because I don't want to do too much in one video. But we are going to go ahead and get started here. And let me go ahead and just take this. And by the way, guys, this is very funny because this was the exact book that I used in my precalculus course. So that is very interesting because I did not realize that they actually posted it on here on the internet. So it's very funny because this is the exact same book I used in my precalculus class, and yes, I have a lot of memories from that class. It was very fun for me. So we're gonna go ahead and just go over the basics now. What I just want to do a little overview of everything that this class covers. So obviously it is a lot of algebra review, and the reason why they do algebra review in this class is because they want to prepare you for calculus. Calculus has a lot of algebra, and obviously they want to make sure that you are up to date with all of these things to make sure you are prepared for calculus. That is especially if you are a math major, or if your major actually needs calculus. Then yes, you are definitely going to have to understand how to do all of this stuff and in preparation for calculus. So regardless of the fact that I did do trigonometry and algebra together, this is precalculus, and it has a few things that I probably did not go over in videos. So with that being said, guys, let's get started. Okay, so we're gonna get started on section or rather on chapter 1. These are fundamentals. So obviously it's a little bit different than the algebra part, because you review certain concepts that you've seen before, and obviously the properties of negative numbers, etc. The reason why they do this is to prepare you for what's coming up in calculus, and they want to make sure that you understand how, algebraically, how this all works, especially this part here, which we did go over in the algebra portion. So in section 1.1, obviously, we are going to get started on, let's see here. So obviously, let's actually, hold on, give me 1 second, guys. Okay, so we're going to go ahead and get started on section 1.2, because 1.1 just talks about, you know, basically just a lot of, you know, a lot of arithmetic problems, which when you get to calculus, you won't use a lot of arithmetic. I mean, of course, yes, you do use arithmetic, but that is very, very simple. And calculus has more, like, algebraic stuff. And so, we are going to get started with section 1.2. Now, this first part, and actually, let me go ahead and... Alright, so we're going to go ahead and start with section 1.2 because obviously it just goes over like the algebraic parts. Like this is kind of what you learn in college algebra, yes, but they are doing this in a very brief, like this book is very brief in algebra, and then it goes on to trig and other concepts that, so it is not all algebra in this class. Give me 1 second. Okay, so it says using the exponential notation, we can write the product 5 times 5 times 5 times 5 times 5 times 5 as, and we can write that as 5 raised to the 1, 2, 3, 4, 5, 6 power, to the 6th power. And then it says in the expression, the number 3 is called the, I think it's the base, if I'm correct. Give me a second. So it would be, hold on. I believe it's in here somewhere. I just want to make sure that I'm actually doing this correctly. So yes, a is the base and n is the exponent. So if we go back here to where we were, 3 is called the base, and 4 is called the exponent, right? When we multiply 2 powers with the same base, so anytime you multiply the powers, or multiply two powers with the same base, we add the exponents. So 3 to the 4th times 3 to the 5th is going to be 3 to the 8th, or 3 to the 9th, excuse me. When we divide 2 powers with the same base, we subtract the exponents. So 3 to the 5th over 3 squared is 3 cubed, basically. And then it says using exponential notation, we can write the cubed root of 5 as, that means, so basically when you have the nth root of x to the m, that would be an exponential notation, would be x to the m over n. So this would be 5 to the 1/3 power. Using radicals, we can write 5 to the 1/2 as, and it's going to be the square root of 5 to the 1st, basically. So that's because you would have the square root of 5 to the 1. It says, is there a difference between the square root of 5 squared and the square root of 5 quantity squared? I believe, so no, because that's not true, because when you have the square root of 5 squared, that'll give you the square root of 25, and that is 5, because it's the positive square root, and then if you do the square root of 5's quantity squared, you're getting rid of the radical, that's also equal to 5, so there's no difference. Okay, so it says explain what 4 to the 3 halves means and calculate 4 to the 3 halves in 2 different ways. So this, the way we can do this one is we can say that this is equal to 4 to the 1 half cubed, which is 4 to the 3 halves, and then we can say 4 to the 3 times 1 half, which is also 4 to the 3 halves, okay? This is very quick. I'm not going to go over it very, like, especially with this class, everything that I ever did in college algebra, like now, it's just very quick. I'm not gonna do this slowly again because in Precalculus, they go over this very quickly. That's the thing, that we're gonna go over functions extremely quickly in this, with these videos, since with college algebra it was more in depth, and now with this class it's going to be very quickly. Okay, so use the following steps to rationalize the denominator. So to do this one, you're just going to go ahead and multiply by the square root of 3, and this will give you, so 1 times the square root of 3 is square root 3, and then square root 3 quantity squared is just 3. Okay, so that would be your answer. Number 6, it says find the missing power in the following calculation. 5 times 1/3 times 5 to the something equals 5. So if you kind of do this, so you can say 5 to the 1/3 times 5 raised to the x is equal to 5 to the first. So you can say, using the properties of exponents, that x plus 1/3 equals 1. This means that if you multiply both of them by 3 to get rid of the fraction, you get 3x plus 1 equals 3, and this gives you x equals, or 3x equals 2, so then x equals 2/3. So your answer for this part would be 2/3, okay? Okay, so it says, is the expression 2/3 to the negative 2 equal to 3/4? So this one, you have to do, so basically for A, it would be 1, so anytime you have a negative exponent, you would do 1 over 2/3. So anytime you have 1 over, or a to the negative n, it would be 1 over a to the n. So this one would be, it would be 1 over 2/3 quantity squared, which is 1 over 4/9, which is 9 over 4. So no, this is not equal to 3/4. Now it says, is there a difference between negative 5 to the 4th and negative 5 to the 4th? Yes, because when you say negative 5 raised to the 4th power with parentheses, you're saying negative 5 times negative 5 times negative 5 times negative 5. And if you say negative 5 to the 4th, this is just negative 5 times 5 times 5 times 5. So yes, there's a difference. One of them is going to be negative, and the other one is going to be positive. Okay, so it says, is the expression x squared quantity cubed equal to x to the 5th? So no, because x squared quantity cubed is equal to x to the 2 times 3, which is x to the 6. You always multiply the powers. You don't add them when you have that. That means when you have x to the a times p power, it would be x to the AP, okay? Is the expression 2x to the 4th quantity cubed equal to 2x to the 12th? Now, this one's interesting. So this one is no, because you have to always square both terms. It would be 2 cubed x to the 4th cubed, right? So this is a no, because you have to have So 2x raised to the 4th power is really 2, or excuse me, hold on. It's 2x to the 4th hold on, guys. Okay, so this one would be 2, so you have 2. Okay, so this one would be, it would be 2 cubed times x to the 4th quantity cubed. So no, this wouldn't be equal to that. Now, the square root of 4a squared is the expression the square root of 4a squared equal to 2a. This is a yes, because remember, if you have the square root of 4a squared, this is equal to the square root of 4 times the square root of a squared. So it's going to be 2, and the square root of a squared is just a. So yes, it would be. Is the expression the square root of a squared plus 4 equal to a plus 2? No, it's not, because this is not, so a squared plus 4 is not equal to the square root of a squared plus the square root of 4. You can never say that. When it has a square root of something, unless it's multiplied, like if this was multiplied, then yes, they could say, oh, it's 2a. Like if they said, like over here when they said for the square root of 4a squared equals 2a, yes, that's true because it's multiplied. But this one is added. You can't say, it's like if I said the square root of 2 plus 3, this is equal to the square root of 2 plus the square root of 3. Well, the square root of 2 plus 3 is 5, and the square root of 2 plus the square root of 3, if you put that on the calculator, that would be equal to 3.14, which is not equal to the square root of 5, because the square root of 5 is 2.23. Right? So no, it's not equal. Okay, so number 33. Or no, sorry, which one was it? Number 9. It says, write each radical expression using exponents and each exponential expression using radicals. Okay, this one, so 1 over square root 3, the exponential expression would be, so obviously, it would be 1 over 3 to the 1/2. Now remember that 1 is equal to 3 to the 0 power over 3 to the 1/2, and whenever you have 3 to the m over 3 to the n, this is 3 to the m minus n, so it'd be 3 to the 0 minus 1/2. This is 3 to the negative 1/2. Okay. The cube root of 3, or the cube root of 7 squared. So this is equal to, again, it's the nth root of a to the m. So in exponential form, it would be a to the m over n. Here, n equals 3, so it would be, or rather, m, as in Mary, is equal to 2. So it'd be 7 to the 2/3 power. Okay. This one, 4 to the 2/3 power, this is equal to the cubed root of 4 squared. Okay. So that's how you would do that one. I don't think that, I mean, obviously you can simplify this, but, basically, I don't think they're telling us to simplify it all the way. You can. If we were to simplify this, it would be the cubed root of 2 cubed times, and then it would be times 2, which is really 2 times the cube root of 2. That's what this is equal to. But that's only if they ask you to like simplify it all the way. I don't know if there's, I'm doing it both ways because I don't know if they're asking us to simplify it all the way. Okay, so this next one, 10 to the negative 3 halves, in exponential or radical, in radical form, it would be the square root of 10 to the negative 3, which is really just the square root of 1 over 10 cubed, which is just 1 over, basically the square root of 1 over the square root of 10 squared times the square root of 10. This is equal to 1 over 10 square root 10, which is just the square root of 10 over 100. Okay. At least that's what I think it is. Give me a second. Okay, yes, it is. It is. So this one, this number 12, is number 12 is oh Lord, hold on. Number 12 is square root 10 over 100. Okay. And no, you cannot simplify this any further, because the square root of 10 is a square root. It is going to be a decimal. And just because they multiply or they divide by 100, or basically like, this is not, you can't just do it the same way that you did a fraction. Like if it were 10 over 100, no. The square root of 10 is a decimal, so if you have this, then yes, this is your answer. Okay, so the number 13, the fifth root of 5 cubed. So in exponential form, this would be 5, and then obviously your this is m, this is n, so 5 to the m over n would just be 5 to the 3/5 power. Okay. Okay, so 2 to the negative 1.5 power. This is the same thing as, so we can turn negative 1.5 into a fraction. This is negative 1 5/10. So if we turn it into a fraction, it's negative 10, so it's negative 15 over 10. And if we divide by 5 on both sides, top and bottom, we get negative 3 halves. So for this one this is equal to 2 to the negative 3 halves. So basically you're going to get the cubed root of 2 to the negative 3. This is equal to the cubed root of 1 over 2 cubed. This is equal to the cubed root of, oh wait, give me a second, no, my bad. It's the square root, not the cubed root. So the square root of 2 to the negative 3, and that's equal to the square root of 1 over 2 cubed. So then that's equal to the square root of 1 over the square root of 2 squared times square root 2, which is 1 over 2 square root 2, which is equal to, and if you rationalize the denominator, it would be the square root of 2 over 4. At least I think. Yes. Because you would just do times the square root of 2 on top and bottom, and that would be the square root of 2 over 4. a to the 2/5, that's just the 5th root of a squared. 1 over x to the 5th, that's just x to the, so x, the square root of x to the 5th, obviously that's x to the 5th raised to the 1/2 power. Now, if there is a 1 on top, this is going to be equal to the negative. So basically, anytime you have 1 over a, this is equal to a to the negative 1. So this one is going to be x to the negative 5/2. Okay, so it says evaluate each expression. So negative 2 to the 6, that's just, how much is that? That's, so negative 64. Negative 5 cubed, that's just negative 125. 5 over 3 to the 0, that's 1. And then 2 to the negative 1, this is 1/2. So it's just 1/2. Negative 2 cubed is negative 8. And anything to the 0 power is just 1, so it's just going to be negative 8. 5 cubed times 5, that's, well, you can write it as 5 to the 4th, or you can also say, using a calculator, you can also say it's equal to 625. 3 to the 8th over 3 to times 3 to the 5th. Obviously, I mean, in reality, I wouldn't use a calculator for these because I don't think that for these ones, it's very necessary to simplify it all the way. So it's just going to be 3 to the 13th. Okay. 3 times the cubed root of 16. I'm trying to think about that one. Okay, interesting. Okay. We can say that this is equal to 3 times the cubed root of 8 times the cubed root of 2. So this is 3 times 2 times the cubed root of 2. So this is 6 times the cubed root of 2. You have to use your algebra skills for this. 2 times the cubed root of 81. That one, so let's see. You can do 2 times, let's see here, because we have 9 times 9, then we have 3 times 3, and then we have 3 times 3, right? Now you can say 2 cubed root of 3 times, or the cubed root of 3 cubed times the cubed root of 3, right? These two cancel out, so you're going to get 2 times 3 times the cubed root of 3. So it's 2. So basically, it's going to be 6 cubed root of 3. Okay. The square root of 3 times the square root of 15. So, okay. This can be, this right one, the square root of 15 can be set as 3 times, the square root of 3 times 5. Now we have the square root of 3 times this, times 3 times 5. This is equal to the square root of 3 quantity squared times the square root of 5. This is equal to 3 square root 5. Okay. The square root of 10 times the square root of 32. This is equal to let me actually do these on my OneNote instead, because I kind of don't want to do this without my OneNote. So let's see here. Okay. The square root of 10 times the square root of 32. So the square root of 10 times the square root of 32. That's just equal to, so basically we can say that the square root of 32 is 8 times 4, and this is 4 times 2, so we have the square root of 2 times 5, sometimes you have to really factor these numbers out, times the square root of 4, times the square root of 2, times the square root of 4, so basically you have the square root of 2 times the square root of 2 times the square root of 5 times the square root of 4 times the square root of 4, which is equal to, this is the square root of 2 times the square root of 2 is 2, and then times the square root of 5 times this end of itself is, in and of itself is 4. So you're going to have 2 times 4 times the square root of 5, which is 8 square root 5. Okay. And this is 2 times the square root of 2 times 5. So yeah, it would be 8 square root 5. Number 27, it says, oh, and, well, I forgot to do the rest of these. Hold on. Well, we'll just go like this. So 17a, I'm just going to put 17a. This was number, or actually it was number 25a. So number 26a, or actually, no, this was 26a, my bad. Number 27a will be this one. I'm terrible at writing with my mouse. This one. 27a, so the square root of 132 over the square root of 3. Okay. So, to do this, you're going to have to rationalize the denominator. Remember when we have the square root of a over the square root of b, this is equal to, so basically you're going to do times the square root of b over square root b, so it's going to give you the square root of ab over b. So basically this one will be, you're going to do times the square root of 3 on top and bottom. This is going to be the square root of 132 times the square root of 3 over 3. And the square root of 132, if you use your calculator, you can do 132 divided by 4. So in reality, this is equal to the square root of 4 times 33. So like this, and then you have times the square root of 3 over 3, and then it would be the square root of 4 times 11 times 3 times the square root of 3 all over 3, and this part here would be then equal to the square root of 4 times the square root of 11 times the square root of 3 times the square root of 3 over 3, and then this would be, so the square root of 4 is 2, and then we just have the square root of 11 because we can't simplify it, and then the square root of 3 quantities squared is just 3, all over 3, so then this would cancel out and you are left with 2 times the square root of 11. Okay, that's how you do that one. Let's see here. A lot of problems on this section. And I'm trying to go as fast as I can. We're not going to do all of them on this section, but we are going to do the ones that, like, the ones that, you know, the ones in which we already reviewed this in college algebra. So, we're going to do 27, so 27, or 28A, rather. It says, let me write it down, the fifth root of 1 over 8 times the fifth root of 1/4. This is equal to, so anytime you have two different square roots, or any nth roots, you bring them together. This is equal to the fifth root of 1/8 times 1/4. This is equal to the fifth root of 1/8. So basically 1 over 8 times 4, which is equal to the fifth root of 1 over 32. Now this is equal to the fifth root of 1 over the fifth root of 32. Now, if you think about it, so you have 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. Notice how it keeps multiplying by 2 every single time. 2 to the 5th, so 2 to the 5th is 32, right? So therefore you're going to have 1 over, and it's going to be the fifth root of 32, that's going to be 2. So this is your answer. It's 1/2. And number 29A, right? I'm trying to go as fast as I can with these. Or let's do 27B, because I feel like, or sorry, it's 17B. Negative 2 to the 6. So this is really simple. It's really negative 2 cubed times negative 2 cubed. Or sorry, no, times 2 cubed. Excuse me. So this is going to be equal to, or wait a minute, it would be, oh lord, negative 2 to the 6, so it would be, give me a second. So you can always just do negative 2 quantity cubed times negative 2 quantity cubed. This is equal to negative 8 times negative 8, which is 64. Okay. Negative 5 cubed is just negative 125, obviously. Negative, or 2 to the negative 3 over 3 to the 0, that's just going to be 2 to the negative 3 over 1, which is 2 to the negative 3, which is equal to 1 over 2 cubed, which is equal to 1 over 8. Okay. Negative 2 to the negative 3 times negative 2 to the 0. This is just negative 1 over 2 cubed, which is negative 1 over 8. Okay. 5 to the 4th times 5 to the negative 2. This is just 5 to the 4 plus negative 2, which is 5 squared, excuse me, which is 25. 10 to the 7th over 10 to the 4th, that's just 10 cubed, and that is 1,000. Okay, the square root of 18 over the square root of 81, or excuse me, yes, the square, or over the square root of 81. This is just the square root of 18 over 9. and this is equal to the square root of 9 times 2, which is over 9, which is equal to the square root of 9 times the square root of 2 over 9, which is equal to 3 square root 2 over 9, which if you look at it, it would be 3 times, so 3 times the square root of 2 over 3 times 3. You cross this one out, and you get the square root of 2 over 3. That's what it would be. So this is square root of 2 over 3. The square root of 18 over the square root of 25. So this is the square root of 18 over 5, which is equal to the square root of 9 times 2 over 5, which is equal to 3 square root 2 over 5. Like at this point, it has to be very fast when you do these, because these have been reviewed a lot in previous algebra courses. So if I'm going very fast, I do apologize, because obviously this is just review. It's not very, very difficult. The square root of, so this one, the square root of 48 over the square root of 3, this is just equal to, so it's going to be the square root of 3 times 16 over the square root of 3. This is equal to the square root of 3 times the square root of 16 over the square root of 3. This cancels out. We are left with the square root of 16, which is equal to the square root, or rather, which is equal to 4. The square root of 54 over the square root of 6. This is equal to the square root of 6 times 9 over the square root of 6, which is equal to the square root of 6 times the square root of 9 over the square root of 6. This cancels out. We get the square root of 9, which is equal to 3. Okay. So this one's 3. And then this one is 4. Oh wait, give me a second. No, hold on. This one's 3. This one is 4. And this one is 3 square root 2 over 5. Okay. Alright, so then the cubed root of 2 times the cubed root of 32. So this is equal to the cubed root of 2, and then the cubed root of 32, that's the cubed root of 8 times 4, which is equal to the cubed root of 2. So all of this is equal to the cubed root of 2 times the cubed root of 8 times the cubed root of 4, which in reality is going to be, so the cubed root of 8 is 2 times the cubed root of 2 times 4, right? And then you would say 2 times the cubed root of 8. And this would be 2 times 2, which is just 4. Okay. Okay, so this one, the sixth root of 1/2 times the sixth root of 128. So you're going to bring this together. You're going to say the sixth root of 128 over 2. This is equal to the sixth root of 64. This is equal to the sixth root of 2 cubed times 2 cubed, and then this is equal to 2, so basically it's equal to the 6th root of 2 cubed times the 6th root of 2 cubed, which is just 2 cubed, which is just 8. Because these roots cancel out once they're brought together. Or actually, hold on. Oh wait, excuse me, my bad. I'm going a little too fast. So this one is the 6th root of 2, and then you're going to go ahead and add these two exponents. It's going to be 2 to the 6, and this is just 2. Okay, so that's the answer. Okay, so this one is 1/5 squared times -3 cubed. So it's 1 over, so it's 1 squared over 5 squared times -3 times -3 times -3, which is 9 times -3, which is -27. So it's going to be -27, and you're going to do, so it's -27 over 25. And you can't simplify it any further, so that would be your final answer. Okay, this one, -5 quantity squared times 2/5 quantity squared. It would be 25 times 4 over 25, which is canceled out, and you get 4, okay? Okay, so 2/3 to the -2, that's just equal to 1 over 2/3 quantity squared, which is 1 over 4/9, which is equal to 9 over 4. Okay, that's number, that's part C, 19C. 20C is -3/5 to the -3. This one would be, so you have 1 over -3/5 quantity cubed. This is equal to 1 over -3 quantity cubed over 5 cubed, which is equal to 1 over -27 over 5 times 5 is 25 times 5 is 125, which is equal to -125 over 27. And this cannot be simplified any further, so this would be your final answer. Okay, so 2 squared cubed is really just 4 cubed, and 4 cubed is 64, so that's how you do that one. Okay, so 3 to the 5th to the 4th is really just 3, so you would say 3 squared quantity squared, and then to the, it would be, so, oh gosh, how do I do this? This is equal to 3 to the 20th power, right? This is equal to 3 to the 10th quantity squared, and 3 to the 10th is equal to 3 to the 5th quantity squared, and 3 to the 5th is equal to 3 squared times 3. So, and then 3 to the 4th is really just 3 cubed times 3, which is equal to 81. So basically this is 81 times 3, that's 3 to the 5th. You get 243, and then that is what you get for, so basically 3 to the 10th is 243 squared, right? Or you can also say 3 squared to the 5th, really. That's 9 to the 5th, which is equal to 9 squared times 9 squared times 1. And 81 squared. So basically, 81 squared equals 6,561, right? And let's see. I mean, in reality for this one, you would just say 243 squared, which is just, it's a really big number, but it's 59,049. That's what it would be. Or you can just say 3 to the 20th if they're not asking for a real number. So this one would be like 3 to the 20th. The square root of 27 over the square root of 4. So basically the square root of 27 over 4, that's going to be equal to the square root of 27 over the square root of 4, which is just the square root of 27 over 2. The square root of 27, like the quantity square root of 27, all over 2. The square root of 12 over 49, that's equal to the square root of 12 over 7. Okay. The cubed root of 24 times the cubed root of 18. That's equal to, so, okay, this is the cubed root of 6 times 4 times the cubed root of 6 times 3. So then we have the cubed root of 6 times the cubed root of 6 times the cubed root of 4 times the cubed root of 3. That's going to be equal to, so this is the cubed root of 36 times the cubed root of 12. Actually, we can say that the cubed root of 24 is equal to the cubed root of 8 times 3. And then the cubed root of 18, we can just say that's like the cubed root of 9 times 2. So, in reality, it would be like the cubed root of 8 times the cubed root of 3 times the cubed root of 3 times 3 times the cubed root of 2. So, this would be 2, and then the cubed root of 3 cubed is just 3, because, like, all of this is the cubed root of 3 cubed, and that would just be 3, and then you just have times the cubed root of 2. So it'd be 6 cubed root of 2. Okay, so this one says the cubed root of 15 times the cubed root of 75. So we have the cubed root of 5 times 3, and then we have times the cubed root of, I'm trying to think, 5 times 5 times 3. So this means that we have the cubed root of 5 times the cubed root of 5 times the cubed root of 5 times the cubed root of 3 times 3, which is equal to, so this is really just 5 times the cubed root of 9. Okay, so the fourth root of 1 over 4 times the fourth root of 1 over 64. Okay. Oh my lord. So this one, it's going to be 1 over the fourth root of, so it's going to be, let's see. Okay, so it's going to be the square root, so 1 over the fourth root of 2 squared times 2 squared times 2 squared times 2 squared. That's going to be, basically, so we have 1 over the fourth root of 2 to the fourth times 2 to the fourth. And that would be 1 over, so it would be 1 over the fourth root of 2 to the fourth times the fourth root of 2 to the fourth, which is 1 over 2 times 2, which is 1/4. Okay, so this one says the cubed root of 4 over the cubed root of 108. So I went ahead and said this is equal to the cubed root of 2 squared over the cubed root of 4 times 27. Now, this is equal to the cubed root of 4 over the cubed root of 4 times the cubed root of 27. These two cancel out. We're left with 1 over the cubed root of 27, which in reality is just 1/3. So that's the answer for this one, is 1/3. Okay, so for these next ones, they're exponents. So x cubed, so the first one is x cubed times x to the 4th. We're going to do, this is equal to x to the 4 plus 3, which is x to the 7th, okay? Y to the 5th times y squared, that's y to the 7th. X to the negative 5th, negative 5 times x cubed, that's x to the negative 2, which is equal to 1 over x squared. Y squared times y to the negative 5th, that's y to the negative 3, which is equal to 1 over y cubed. And then 2y squared all cubed, that's 2 cubed times y squared cubed, which is equal to 8 y to the 6. 8x quantity squared, that's just 8 squared times x squared, which is 64x squared, okay? W to the negative 2 times w to the negative 4 times w to the 5th. So it's w to the negative 2 plus negative 4 plus 5, which is w to the negative 6 plus 5, which is 1 over w, because it's w to the negative 1, which is 1 over w. Z to the 5th times z to the negative 3 times z to the negative 4. This is z squared times z to the negative 4, which is z to the negative 2, which is 1 over z squared. Okay. Okay, so this one is, so basically you have y to the negative 2 times y to the 7th, that's y to the 5th. Y to the 4th, or x to the 4th times x to the negative 3, that's x to the first power, which is just x. So that's how you would do that one. And then x to the 16th over x to the 10th, that's just x to the 6th, because it's, you'd subtract these two. Okay, it says y to the 7th times y to the 0. So that's going to be y to the 7th times 1 over y to the 10th, which is y to the negative 3, which is just 1 over y cubed. Okay. A to the 9th times a to the negative 2 over a. This is equal to a to the 7th over a, which is a to the 6th. Z squared times z to the 4th over z cubed times z to the negative 1. That's just z to the 6th over z squared, which is z to the 4th. A squared times a to the 4th cubed, that's just a, so you're going to add these two, a to the 6th cubed, which is just a to the 18th power. X, so basically, okay, so this one is x cubed over 2 cubed, which is 8, times 5x to the 6th, so over 1, which is equal to 5x to the 9th over 8. Okay, this one says 2a cubed a squared all to the 4th. This is equal to, so it's 2 to the 4th times a to the 5th raised to the 4th power. So it's going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, a raised to the 20th power. Okay, we're going over this really fast because obviously we've seen this time and time again with algebra. 3z squared, negative 3z squared quantity cubed times 2z cubed. So it would be negative 6. So give me a second. It would be, so negative 3 quantity cubed, that's negative 27z to the 6, and then times 2z cubed, that's just equal to negative 54z to the 9th. Okay. Oh my. Give me 1 second, guys. Okay, so this one says 3x cubed y squared times 2y cubed. This is just, so it's 3x cubed times y squared times y cubed times 2. This is 3 times 2 times x cubed, and then y squared times y cubed, that's y to the 6. So this would be 6x cubed y to the 6. Okay. Okay, so this one is 5w squared z to the negative 2 quantity squared times z cubed. So this one is going to be 5 squared w squared quantity squared z to the negative 2 quantity squared times z cubed. This is equal to 25w to the 4th z to the negative 4 times z cubed, which is equal to 25w to the 4th over z to the 4th times z cubed, which is equal to 25w to the 4th z cubed over z cubed times z, which is equal to 25w to the 4th over z. Okay, so this one says 8m to the negative 2 times n to the 4th times 1/2 n to the negative 2. So we have to go ahead and we're going to get we have the two of them together, right? And then it's going to be 4, and then m to the negative 2 is just, it goes on the bottom, so it's 4 over m squared times n squared, okay? So it's going to be 4n squared over m squared, okay? So this one says 3a to the 4th b to the negative 2, all cubed. So basically we have 3 cubed times a to the 4th cubed times 1 over b squared, all cubed, times a squared times 1 over b. So basically we're going to have 27a to the 12th times a squared all over b, which is equal to, or b cubed, excuse me, which is equal to, and we have 27a to the 14th over b cubed. That would be our answer. And sorry, by the way, guys, that was 36b, okay? Okay, so 37a is x squared y to the negative 1, so we're going to go ahead and do x squared. So it's going to be x squared over y over 1 over x to the 5th. This is just x squared over y divided by 1 over x to the 5th. And so this is going to equal x squared over y times x to the 5th, which is equal to x to the 7th over y. Okay, so this one is a cubed over 2b squared all cubed. So it's going to be a to the 3 times 3 power over 2 cubed b squared to the 3rd power, which is equal to a to the 9th over 8b to the 6. Okay, this one says y to the negative 2, z to the negative 3 over y to the negative 1. So it's going to be 1 over y squared times 1 over z cubed over 1 over y, which is equal to 1 over y squared z cubed over 1 over y, which is equal to 1 over y squared z cubed divided by 1 over y, which is equal to 1 over y squared z cubed times y, which is equal to y over y times z cubed, which is equal to 1 over yz cubed. Okay, so we have x cubed y to the negative 2 over x to the negative 3y squared all squared, excuse me, all to the negative 2. Oh my goodness. So this one is going to be, so we're going to work on the inside first. We have x to the 3 minus negative 3, y to the negative 2 minus 2, and this is all to the negative 2 power. So then it's going to be x excuse me, x to the negative, so it's 3 plus 3, and then we have y to the negative 4, and then all to the negative 2, so then it's going to be x to the negative 12, y to the 8th power, which is really just y to the 8th power over x to the 12. Okay. Okay, so this one is a squared over b to the 5th, all to the 5th, and then times a cubed b squared over c cubed, all cubed. So basically we have a to the 10th over b to the 5th times, it's a to the 3 times 3, that's a to the 9th, b to the 6 over c cubed. This is equal to a to the 19th, b to the 6 over b to the 5th c cubed. This is equal to a to the 19th, and then it's b, and then it's all over c cubed. Okay. Okay, this one is going to be, so this one, number 39b, is going to be, so we have u to the negative 1 to the 2nd power, that's u to the negative 2, and then v squared squared is just v to the 4th over, and it's going to be u cubed cubed, which is u to the 9th, v to the negative 6, so it's going to be u to the negative 2 minus 9, and then v to the 4 minus negative 6, which is equal to u to the negative 11, v to the 4 plus 6, which is equal to u to the negative 11, v to the 10th, which is really just v to the 10th over u to the 11th. Okay. Okay, so 48 is x to the 4th z squared over 4y to the 5th times 2x cubed y squared over z cubed quantity squared. Okay, so this one, the way we're going to do this one, the left part stays the same because we have nothing to cancel out, and then this part is actually going to be 2 squared x cubed squared z squared squared divided by z cubed quantity squared. This is equal to x to the 4th z squared over 4y to the 5th times 4x to the 6 z to the 4th over z to the 6, which is equal to 4x to the 10th z to the 6 over 4y to the 5th z to the 6. Now, the 4's cancel out, the z to the 6 cancels out, and we are left with x to the 10th over y to the 5th. Okay. Okay, so the 40b, rs squared quantity cubed over r to the negative 3s squared quantity squared. So it's going to be, so this is going to be r cubed s to the 6 over r to the negative 6 s to the 4th. So it's going to be r to the 3 minus negative 6 s to the 6 minus 4. So it's going to be r to the 3 plus 6 s squared. So it's r to the 9th s squared. Okay, and that's our final answer. Alright, so this one says 8a cubed b to the negative 4 over 2a to the negative 5th b to the 5th. So this one is, so obviously 8 over 2 is 4, so it's going to be a cubed over a to the negative 5th, that's a to the 3 minus negative 5, b to the negative 4 minus 5, so it's going to be 4a to the 3 plus 5, b to the negative 9, so it's going to be 4a to the 8th, b to the negative 9, so it's going to be 4a to the 8th over b to the 9th. Okay. Okay, so this one we're going to do, so it's going to be y to the negative 3 over 5 x to the negative 2 raised to the negative 3, so it's going to be 1 over y cubed over 1 over 5 cubed times 1 over, or rather, times x to the 6. So it's going to be 1 over y cubed times 5 cubed, and then times 1 over x to the 6. So then it's going to be 125 over y cubed x to the 6. Oh, and my bad, that was 41b. Okay, my bad. Okay, so this one says 5xy to the negative 2 over x to the negative 1y to the negative 3. So we have, it's going to be 5x to the 1 minus negative 1, and then it's going to be y to the negative 2 minus negative 3. So it's going to be 5x to the 1 plus 1, y to the negative 2 plus 3. So it's going to be 5x squared y. Okay. Okay, so number 43a is just going to be, so this is just b cubed over 3a. Okay. Okay. Oh, and, my bad, I was doing, let's see, hold on. Where was I? Okay, so number 42a was 5x squared y. 41b was 125 over y cubed x to the 6. So, and then 42b was, okay, so 42b is the one that we were working on. This one, so you're going to do, it's 2 to the negative 3, a cubed, b to the negative 3, over a squared, b to the negative 3. So obviously b to the negative 3 cancels out, and we are left with 1 over 8, and then a cubed over a squared is just a. So if we do this over 1, this would just be a over 8. Okay. Okay, this one is q to the negative 1, r to the negative 1, s to the negative 2, all over r to the negative 5th, sq to the negative 8, all to the negative 1. So we're going to do the inside first. Q to the negative 1 over q to the negative 8 equals q to the negative 1 minus negative 8, which is q to the negative 1 plus 8, which is q to the 7th, right? So we already dealt with that. And then r to the negative 1 over r to the negative 5, that's just r to the negative 1 minus negative 5, which is equal to r to the negative 1 plus 5, which is r to the 4th. And then s to the negative 2 over s, that's just s to the negative 2 minus 1, which is s to the negative 3, which is 1 over s cubed. Okay, and now they want us to do all of this. So basically, q to the 7th, r to the 4th, over s cubed, all to the negative 1 power. This is just flipped over, because so basically a over b to the negative 1 is just b over a. So basically this would be s cubed over q to the 7th, r to the 4th. Okay. Okay, so 44a says s squared t to the negative 4 over s to the negative 1t. So we have s squared, so it's s to the 2 minus negative 1 power, t to the negative 4 minus 1 power, right? So it's going to be s to the 2 plus 1, t to the negative 5, so that's going to be s cubed t to the negative 5, and then t to the negative 5 is just goes on the bottom, so it's s cubed over t to the 5th. My bad, guys, I forgot one more part. This is to the negative 2 power, so then it would be s to the negative 6 over t to the negative 10. This is just 1 over s to the 6 over 1 over t to the 10th, which is 1 over s to the 6 times t to the 10th, which is just t to the 10th over s to the 6. Okay, so that's your final answer. My bad. Okay, this one is, so this one, xy to the negative 2, z to the negative 3, over xy, over x squared y cubed, z to the negative 4, so we have, it's going to be x to the 1, so basically, it's going to be, hold on, x to the negative 1, y to the negative 2 minus 3, z to the negative 3 minus negative 4, all to the negative 3 power. This is x, so basically you do this, right? And it's going to be x cubed y to the negative 5. And then it's going to be times y to the negative 5. Z to the negative, or rather, y to the negative 5z, and then to the negative 3. So it's going to be x cubed times 1 over y to the 5th times z to the negative 3, or rather 1 over z cubed, excuse me. So this is going to be x cubed over y to the 5th z cubed. Okay, so radicals. This is simplify the expression, assume that the letters denote any positive real numbers. So, basically, we have the 4th root of x to the 4th. Now, this is going to be, so it's going to be positive x. So, this is x, right? Now, the 5th root of x to the 10th, that's going to be x to the 10 over 5, so that's x squared. Now the 6th root of 64, a to the 6th, b to the 7th. The 6th root of 64, if you think about it, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, so it's going to be 2 to the 6th power. So basically, the 6th root of 64 is 2, and then the 6th root of a to the 6th is just a, and then the 6th root of b to the 7th is just, basically, it's the 6th root of b to the 6th times b, which is equal to 2ab 6th root of b. Okay. Now the 4th root of x to the 4th, that's just x, and then the 4th root of x squared, or of y squared, excuse me, is just square root y, and then the 4th root of z squared is just square root z, so it's going to be x square root of yz. Okay. This one is the 4th root of 16x to the 8th, so it's going to be the 4th root of 16, that's going to be, oh, I'm trying to think. So, give me 1 second. Okay, so this one is the 4th root of 2 to the 4th times the 4th root of x to the 8th, which is equal to 2x to the 8 over 4, which is 2x squared. Okay. Okay, so this one is the cubed root of y cubed, right? So it's going to be the cubed root of y cubed, that's, oh god, that's x, and then y to the 6 over 3, which is xy squared. Okay, this one is, okay. Oh lord, this one is gonna be equal to cubed root of 64a to the 6th power b squared. Now, the cubed root of 64 is 4, and then you have a to the 6 over 3, that's a squared, and then b squared, so that's going to be b to the 2/3, basically, which is just the cubed root of b squared, so basically you have 4a squared times the cubed root of b squared. Okay, now this one says the cubed root. So this one says the cubed root of 64, the cubed root of the square root of 64x to the 6. So basically we have the square root of 64 times the square root of x to the 6. This is 8x cubed, right? And we have to take the cubed root of that. So it's going to be the cubed root of 8 times the cubed root of x to the 6. This is just 2, and then x to the 6 over 3, which is 2x squared. Okay. All right. This last, well, it's not the last part, but we're very close. So basically, okay, the square root of 32 plus the square root of 18. This is just the square root of 8 times 4 plus the square root of 6 times 3, which is equal to the square root of 4 times 2 times the square root of 4 plus the square root of, actually it's going to be the square root of 9 times the square root of 2, and then you have, so basically the square root of 4 squared times the square root of 2 plus 3 square root 2, so it's going to be 4 square root 2 plus 3 square root 2, which is 7 square root 2. That's what it would be. So this is 7 square root 2. Okay, so this one, 49b, says square root of 75 plus square root of 48. So it's going to be, okay, so square root of 75 is the square root of 25 times 3, and then plus the square root of 48 is just the square root of, it's going to be the square root of 16 times 3. So then you have the square root of 25 times the square root of 3 plus the square root of 16 times the square root of 3. This is equal to 5 square root 3 plus 4 square root 3, which is equal to 9 square root 3. Okay. Okay, guys, so I think that I'm gonna stop the video here because yeah, I've been recording for like an hour and 22 minutes. So like I said, I don't want to make this video so long either. But this is all algebra review. It's just really brief. So it's fundamentals is what they call it, but in the next section, we're actually going to go over, you know, adding and subtracting polynomials, multiplying algebraic expressions, all of this stuff. So with that being said, guys, this concludes this video, and thank you so much for watching. If you watched, these were just very simple fundamentals of algebra, like that you use for calculus and that you use in pre-calculus as well. So it's just to prepare for calculus, basically. So with that being said, guys, thank you so much for watching, and I will see you guys in the next video. Bye, guys.